Hello everyone, welcome back to the channel. So today we are going to discuss another interview related problems based on arrays in JavaScript. So let's give it a read. What does the problem say? Given an array of integers nums containing n integers where each integer is in the range of 1 to n minus 1 both inclusive. There is only one repeated number in nums. Return this repeated number. So let's understand this problem with the help of an example. Basically, we are given an array. Let's take it as nums as given in the question. So let's suppose the array is like this: 1, 3, 4, 2, 2. So as per the problem, we're given an array of size n. In this case, n, which is the length of the array, is 5. So the number in this array will be in the range of 1 to n minus 1. N minus 1 is 4. So it will be in the range of like 1, 2, 3, and 4. So it is very obvious, like we have 4 numbers and the length of the array is 5. So one of these numbers will going to repeat itself in the array, right? So we have to find that repeated element itself. So what does it comes to my mind when I see this problem? Like the very basic thing which comes to my mind is I can align these elements in ascending or descending order and then just check that which two adjacent elements are equal. Then I can easily get the repeated number. So what does I mean by saying that? Let's suppose this array, if I will sort this array in ascending order, then the elements in the array will become 1, 2, 2, 3, and 4. So then I will just check which two adjacent elements are equal. I will start checking with 1 and 2, they are not equal. Then I will check 2 and 2, they are equal. So the repeated element is 2 itself. So let's take another example. Let's take it as 3, 1, 3, 4, and let's say 2. So again in this case, n is again 5. So numbers are going to be in the range of 1, 2, 3, and 4, right? So if I sort this array, then this array will become something like 1, 2, 3, 3, and 4. So I will start checking with 1 and 2. These are equal. No, these are not equal. Then I will move on and I will check 2 and 3. Are they equal? No, obviously. And then I will check 3 and 3. They are equal. So the repeated element is 3. So let's code this method of solving it. Let's take a function first, which will find the duplicate number. Find duplicate, it will take an array. So initially, first we will sort the array. So we can sort the array using the inbuilt function in JavaScript. So let's suppose array dot sort. It takes a callback. So because we want to solve it in increasing order, so we will do something like this, and then we will just loop over the array dot length and I plus plus. So basically, we have to check the adjacent numbers, right? So I will check if array of I is equal to array of I plus 1, then I will simply return array of I. Alright, so I'll just test it out. Console.log, first pass it nums, and then okay, let's call the function first. Find duplicate nums1, find duplicate, right? Okay, num1, it is nums1. Okay, so one more thing, because I am starting from index 0, so I can, and I am accessing I plus 1th index, so I can traverse a maximum of array dot length minus 1. So basically what does I mean by doing this? Like I am at index 0, so I am checking 0 and 1th element, right? When I am at index 1, I am checking one in element at index 1 and index 2. when I am at second index, I am checking element at second index and element at third index. When I am at element index 3, then I am checking these two elements, right? So I cannot move ahead of this, because if I go to the last element, then I cannot check it beyond this array, right? So I will just iterate over this position, like the second last position, because I have to check it with the last element only, right? So let's test it out. So the answer in this case should be 2, and the answer in this case should be 3, right? Yes, we are getting 2 and 3. So this approach works. But what is the time complexity of this solution? Like, so sorting an array takes big of n log n at the worst case, at the best case, right? And then another, we are looping the array again. So this whole will also take big of n. So in whole, this method will going to take something approximately big of n log n, right? So can we optimize it further? Like, can we do it in linear time complexity? Yes, we can do it. Let's discuss that approach as well. So in this approach, what we will gonna do is we will use set in JavaScript. So what does set do in JavaScript? Set basically stores unique values in JavaScript in any other data structure. Set is basically used to store unique values. So what can I do is I will iterate through the array. I will not sort the array this time. So what I will do is I will iterate through each of the elements in the array and check if it already exists in the set or not. If it already exists in the set, then we got the repeated element, right? And we have the functions in set which we can use to check if an array or if a number already exists in the set or not. So let's do this solution as well. So let's create a set first. How can we create a set? Is let s is equal to new set, right? So then just loop through the array is less than array dot length and I plus plus. So we basically check if if the I element at the ith index already exists in the set or not. So how can we do this is a set has a function called has. So we will check as dot has array of I. If it does already has this element, so we will simply return this element, right? If it doesn't have this element, we will simply put it in the set and move on by using add method. Right, so let's test it out as well. So we gonna pass those two arrays only. So we know the answer should be 2 in the first case and 3 in the second, right? So just test it out. Yes, so we are getting the output as required, 2 in the first case and 3 in the second case, right? So what is the like time complexity and space complexity in this scenario, right? So the time complexity will be like we are only traversing the array once, so time complexity will be big of n, right? And what is the space complexity? So in worst case, we will need to store almost all the elements, like minus one elements at worst case in the set. So the space complexity becomes big of n, right? So we improve the time complexity for sure from big of n log n to big of n, but we increase the space complexity. So is there a way by which we can reduce this space complexity to be like big of 1, like in constant space complexity and in linear time complexity? So yes, we can do that as well. So let's discuss that approach as well, right? So we are going to use negative marker approach now to solve this problem. So what does this approach says? Like we will loop through the array first, and then at ith index we will check if nums of I is lesser than 0 or not. If yes, then we will return nums of I. If not, So we will mark the element at nums of I as negative. So what does I actually mean by this algorithm? So let's dry run this approach once. So we will start with 0th index and we will check if element at 1th index, like nums of I is, in this case I is 0, so nums of 0 is 1 and nums of 1 is 3. So we will check is 3 is lesser than 0. 3 is not lesser than 0. We will mark 3 as negative. Right. So what does it actually mean is that I have not encountered 1 earlier. Have I encountered 1 earlier? So 3 was already marked as negative. Right. So let's continue. Let's move on to the next index. So I move on to the first index and I check what is element at first index is 3. So I will check for nums of 3. Nums of 3 is 2. Is this less than 2, less than 0? It is not. So let's mark it as negative. Right. So it was not already negative because I have not encountered 3 earlier. Have I encountered 3 earlier? So this was already marked as negative, right? So let's move on to the next index, which is 2. So I will check nums at 4, right? Nums of 4 is 2. So is 2 lesser than 0? Again not. So I will mark it as negative because I have not encountered 4 earlier, right? So I will move on and come to I is equal to 3. Then I will check what is nums of 2. Nums of 2 is 4, which is again not less than 0. So I will mark it as negative as well. So now I will move on to I is equal to 4. At fourth index it is 2. So I will go on to nums of 2. But nums of 2 is already marked as negative. Why? Because I have already encountered 2. Right. So we have got a repeated element which is 2. So this is what this algorithm is actually doing. Right. So in this case we will simply return 2 as our answer. Right. So let's try run it on this example as well. So things become much more clearer to you. So we will start with I is equal to 0 and we will check for nums of 3. Nums of 3 is 4, which is not lesser than 0. We will mark it as negative. Again, it was not already marked as negative because we have not encountered 3 earlier. Had we encountered 3 earlier, so it was already marked as negative, right? So we will move on and come to I is equal to 1. For I will check nums of 1 is 1 again. So 1 is lesser than 0. No, it is not lesser than 0. So I will mark it as negative, right? Then I will move on. I is equal to 2. I will check nums of 3 because I have to check nums of I. So nums of 3 is minus 4. It is already negative. Why? Because I have encountered 3 earlier. At I is equal to 0, I encountered 3. That is why I marked nums of 3 as minus 4 earlier. So we got a repeated element in nums of I, which is 3. So in this case, we will simply gonna return 3. So we can check that this time complexity in this case is linear because we are only looping through the array only once and we are not using any extra space. So the space complexity is also constant. So this is the best optimized solution we can have for this particular question. So let's code it out. Right, I will first just loop through the array. Right, let's I is equal to 0. I is less than array dot length and I plus plus. So we will store the element at the ith position in a variable, right? So we will just check if array of cur, which cur is nums of I, cur is actually array of I. So this becomes array of I, which we actually need, right? So we will simply check if this is already marked as negative or not. If it is already marked, then we will simply return cur. Otherwise, we will gonna mark it as negative and we can mark it as negatives by simply multiplying it with minus 1, right? So we will check now if this works or not. Okay, so we have to store the absolute of it because we cannot access negative indices. Yes, we got 2 and 3. I hope you understood the solution. If you liked the video, then please hit the like button. Comment me down below for more such videos, and please consider subscribing the channel for more such type of content. Thank you.